Hello. Thank you very much for joining this session on Layer 3 and Layer 2 Data Centre Interconnects. This is an introduction session where we're going to talk a little bit about the reasons why you would use a data centre interconnect, show some topologies as to where they would be used, why Layer 3 would be used via Layer 2, and then in some follow-up videos we're going to talk about some more of the specifics. So without further ado, let's kind of just jump in and start talking about the different deployments and start off with the different reasons for why you would need a data center interconnect. So this is really just based on my experience over the years, different use cases, but there's loads of different use cases and that are specific to different customers. One in particular for a Layer 3 data center interconnect, the reason that you would potentially look at Layer 3 is if, for example, you wanted to use the circuit between the data centers or a circuit between the data centers for a site, as a failover mechanism if, for example, a site's MPLS circuit failed. So we'll talk about that a bit more in a minute. So that would be, again, specifically for users to fail over. So if I was wanting to make an IP telephony call to someone else in the organisation, that would normally, I'd pick the phone up, I'd dial the number, and the traffic would, in this scenario, go over the MPLS circuit at my site and go over the MPLS network. If that MPLS circuit fails, and say I'm in a large HQ building which doubles up as a comms room, is also acts as like a data centre, or has some servers and things like that in it, then I might say, well, instead of getting a second MPLS circuit in this site, I'll use the Data Centre Interconnect to the co-location facility, which also has an MPLS circuit. And then I can make my telephony call instead of going directly over the MPLS. It would take one additional hop to the data centre, or the DR data centre, and then use the MPLS from that site. Another reason that you might want to use a data center interconnect is the traffic flow in the opposite direction. So if I'm a user at a site, at an end remote site, and I access an application in data center 1, and let's say data center 1 has a single MPLS circuit plus a point-to-point circuit to data center 2, and data center 2 also has an MPLS circuit. In normal traffic flow conditions, my application would be accessed via data center 1 and the MPLS circuit. But if that failed, and I only have an instance of the application in one data center, I may want to come in via data center 2 over the data center interconnect via routing, and then access the application that way. And we'll draw this out a little bit in a minute. So the next kind of reason, or the next reason for a data center interconnect might be a Layer 2 data center interconnect. For example, storage replication. That's a common SQL databases, things like that. vMotion is probably the most well-known reason for a Layer 2 data center interconnect. I think there's some advancements from VMware version 6 that vMotion can be done over Layer 3. That aside, there's still other things to consider there, even if you want to do Layer 3 vMotion. Like, for example, if you still need the same subnet in both locations, you're still going to need like some sort of overlay technology. You need to think about things like DNS relating to servers and things like that as well. So we're not going to go into that in detail in this presentation, but Layer 2 data center interconnect for vMotion. So some Layer 3 data centers interconnects facilitate for a Layer 2 data center interconnect. And what I mean by that is the Layer 3, so if I have a provider implement a Layer 2 circuit which terminates on switches in data center 1 and data center 2, and I route between those two data centers, I might still have a requirement for certain services to be on the same subnet. And if we were to do that, we would use the routed link in order to present a layer 2 data center interconnect in an overlay. So an example of that might be something like OTV from Cisco. It could be, if it's IP based, L2TP version 3. If it's MPLS based interconnect, it might be layer 2 VPN pseudo wires or something like that. So as you see, even from this brief sort of high level reasons for having a data center interconnect, you know, there's a number of different reasons, and each of the above you could do a full course or a full day's workshop on each of those and talk about the pros and cons, or layer 2 versus layer 3. So it's a subject matter on its own. I just wanted to give some background as to why you might want a DCI at layer 2 or layer 3 in the first place. So moving on then, what I'm going to do is just switch gears here and bring up a topology, and hopefully I should be able to share my screen. In here. Okay. So just talking about then the couple of scenarios that we were talking about in the slide. We had layer 3 for user failover. So let's say, for example, that what happened there? Let's say, for example, Data Center 1 also has users, okay, and we want to talk to from Data Center 1 to Remote Office 2. That's a terrible picture of a PC, but that's a PC. And then our users at this site has a PC. Now, the normal traffic flow in this scenario would be along the lines of, or it would actually be, this PC would come over the MPLS and it would route directly to this PC. So that might be a telephone. I probably should have drawn a telephone in, but there you go. If this link fails, we still need this traffic flow. Let me change the traffic flow color because red's going to be a bit confusing. So let's say the traffic flow is purple. That's your IP telephony traffic. If that circuit fails, instead of putting another expensive, so let's say this is a 10 gig MPLS, and we want both the primary and the backup circuits to be the same speed, but we don't want to pay for two expensive MPLS 10 gig circuits when one's going to be active and one's going to be standby, when we actually have the capability to route over these or this point-to-point link between between the two data centers. So data center 1 and 2 are connected already. Why not use it for routing traffic? So if this if this circuit is unavailable, then we just route the traffic over here, and that can be achieved by using BGP. So if you let me clear that annotation, and then if we talk about it in the opposite direction, so let's say a user at this remote site, the pen color, yeah, user at this remote site wants to communicate with an application server which is over here. The normal traffic flow, if we go back to a purple traffic flow, is going to be along the lines of, or actually, this will be the traffic flow if the routing is configured that way, obviously. If we have a similar scenario where this link is no longer available, then what we are wanting to do is route traffic via this data center down here and over the interconnect to the server. So that explains like the high level traffic flow. What I wanted to talk about just before we wrap the video up, because in the following videos I'm going to go into some of this stuff in a lot more detail. I want to show you, well, before I do, I just want you to, you're probably looking at this thinking, what's the big deal, right? You know, we've got a data center here, a data center here, and let's say there's a data center / remote office over here. And they've all got circuits in one way, shape or form, but if the circuit fails, we'll just, you know, use the other circuit. That's fine in a small, simple network like this. Let me show you something. If we were to zoom in this data center, in data center 1 and data center 2, let's say these are the two main data centers for the organization. If we were to zoom into that data center or into those data centers, and bear in mind before I put this diagram on the screen, this is still high level. If we look in here, let me clear the annotation. If we look into, this is what a data center or a dual data center may or may not look like, you know, at a basic level. And what we're talking about, I'll just quickly explain what we have here. Yeah. So here and here we have our spine leaf architectures, which are common within data centers. It's spine leaf cross fabric architecture. It might just be non-SDN or it might be SDN enabled, but that's typically what you'll see. And it's for hosting servers and services, basically your access layer in your, if you think about the core distribution access model, then this is like your distribution, your access layer, if you're not familiar with CLOS. We've then got some management tools and an orchestrator. I'm talking vendor specific here, but for example, it might be Cisco ACI, that might be your APIC and multi-site orchestrator, for example. We've then got some core switches in the data center, and what we have in between core switches, the backbone, is what we're referring to as IPN DCIs. Again, it's ACI terminology, but what it basically means is we have IP network, which means it's layer 3, and DCI, Data Centre Interconnect. If we then move up the stack, we've got a WAN aggregation block, a couple of MPLS routers, nothing special really there, connect into the MPLS, or it might not be an MPLS, it might be a VPLS, but the corporate WAN, and then we've got the remote sites out here. And let's say this was like two greenfield built data centers, but you have to integrate into a legacy data center. So if that's the case, then what we need to start thinking about is, well, if we've got servers at the old data center on the old subnets, then we need a layer 2 DCI in order, because we're not going to move, like if we've got hundreds of servers, we're not going to move them all at the same time, because you'll have a mix of physical and virtual more often than not. So we might need to stretch layer 2. So there's a use case for a layer 2 DCI, and then once all the servers are migrated, we remove that DCI, and it might be physical or it might be a DWDM wavelength, it might be an overlay or whatever. Then if we've got any kind of services coming into that legacy data center, so for example, you might have a legacy WAN, I don't know, coming into that data center, then you're going to need layer 3 connectivity and a layer 3 data center interconnect, which is indicated by this blue line here. So that hopefully it gives you a bit of an overview as to when somebody says, oh, I need a layer 2 data center interconnect, or layer 2 versus layer 3 data center interconnect. It's not actually that straightforward, and there's a lot of thought that needs to go into data center interconnects. We're going to cover more in the following videos, but I just want to finish off by talking about a few of the methods and approaches that might be used, or the reasons why. So let me just go back to the presentation and move to the next slide. So what we're talking about here is the technical design aspects and the protocols / approaches typically used for layer 3 data center interconnects. So why this is the technology that's typically used behind deploying a layer 3 data center interconnect. So if we start off by the first one, eBGP. So I mean that's probably quite straightforward for anyone who's experienced in networking. Between data centers, certainly what we're seeing more of now. You might have in the past seen, we just need to be able to route between the data centers, so run the IGRP or OSPF. But as you've seen from that last diagram, where you've got multiple different clouds, interconnects, etc., things are getting more and more complicated, and then you start adding overlays into the mix. The best protocol to run between data centers, in my opinion, in order to be able to provide flexibility from the routing perspective with policy, filtering, etc., is eBGP. So let's say data center 1 is AS 65,000 and data center 2 is 65,002. And then that helps longer term. We'll talk about some of that in the follow-up videos. Why Lisp? Okay, so this is quite a hot topic in some other areas of networking. So, for example, Cisco's software-defined access. Lisp's been around for a few years, and it was typically used in conjunction with technologies like OTV. The thought process behind Lisp is that, let's say we have one subnet between two data centers. Like we need a layer 2 data center interconnect, and the subnet is 10.10.10.0/24. If 10.10, if that's hosted and advertised as a /24 out of data center 1 and data center 2, you might use like BGP, AS prepend or MED or something to make traffic be attracted to data center 1 more so than data center 2. But if one server moves across, let's say 10.10.10.10, you can advertise that as a host route using Lisp, so that 10.10.10.0/24 is still advertised out of data center 1. Let me see if I can just bring that up, just to make it a bit easier to understand. So, if it's advertised out of here, but a server moves across here, then what we can have, if the server is blue, okay, a host route is oops, what happened there? A host route is advertised out to all the sites, and they all come in this way in order to access this server down here that's moved. But for all other traffic going to the 10.10.10 subnet, it would all go via data center 1, because all the other servers on 10.10.10.0 are still here. Hopefully that gives that's 100-mile-an-hour view of I shouldn't have stopped sharing that. That's a 100 mile an hour view of Lisp, so basically injecting host routes. A similar thing can be achieved if you've got like server farms where you have we've covered EBGP, covered Lisp, DNS, global server load balancers. That's basically DNS, using DNS in order to load balance, or you could potentially use Anycast. Yeah, we're probably going to go into too much detail if we start talking about that now. But yeah, we can use global server load balancers and DNS combined with layer 4 virtual IP addresses, mapping the two together. And when a server moves from one data center to another, then that will be propagated throughout the DNS system. And then longest match prefix advertisement is similar to Lisp, but it would be more of a manual thing and not really host routes. But to give you an example, let's say that if I stop annotation just now and bring that diagram back up. Yeah, so if for example we've got a subnet up here that's a /24, and then in the higher range, let's say dot 200 is in this data center, then what we might do is do /25 out here and a /24. So we might advertise, you know, if we go back to the ranges that we were talking about earlier, we might advertise 10.10.10.128/25 and 10.10.10.0/24 out of data center 2, and that means that for this 200, if that's the server in blue, all these would come in this way, but everything else would continue to route up towards data center 1. So that's just, that's bog standard routing logic of longest prefix matching. So yeah, and where that actually fits into data center interconnects is if you're advertising, sorry, I've rubbed it out now, but if you're advertising the /24 and the /25 out of here, what that facilitates for is, if running out of colours, but if this link fails, you can still access from a remote site over the data center interconnect, and that would be a layer 3 data center interconnect, or it might be layer 2. It just depends on how things are configured at the back end. So I'm conscious of this video going on too long because it's only an introduction, but I hope that it gives a good introduction around data center interconnect design, gives some insight as to what some topologies can look like, and we'll follow up in the next videos on some of the detail. So thanks for watching if you made it this far, and speak to you soon. Take care.